Here we're going to be looking at independent and dependent events. Independent events are events that have nothing to do with each other, so that they have no effect on each other. So say if you're flipping a coin, you can flip the coin once, and then if you flip it a second time, your first flip has no bearing on the second flip whatsoever. So you flip it once, and you flip it a second time, you still have a 50-50 chance of getting heads or tails. So the first flip has no effect on the second flip. Dependent events, which we'll get to later, these are events that do actually affect one another. So say, for example, if you draw a card off the top of a deck and then toss it aside and then try to draw a second card, the act of pulling that card off and throwing it to the side and removing it from the deck changes the probability of the second draw. So we're going to start with independent events. Now before we get to this formula here, let's actually go into example one and just do it the long way. So if we're looking for the probability of flipping tails twice in a row, well, let's look at all the options that we have here. So all the ways this could happen. We could get heads on the first flip, and then heads on the second flip. Or we could get tails on the first flip and tails on the second flip. Or we could get heads on the first and tails on the second, or tails on the first and heads on the second. And these are all the different ways that you could flip a coin twice. So if we look at the probability of flipping tails twice in a row, well, that's one of the four possibilities. So that's a probability of 1/4. Now let's do this a different way. So let's use the formula here. So we can get to the same answer by actually just multiplying the probabilities of each of these events together. So for flipping a coin, there's two sides of the coin. So your probability of getting one of the sides is 1 out of 2, or 1/2. And so the probability of getting tails for the first flip is 1/2. The probability of getting tails for the second flip is also 1/2. And if we multiply these together, then on the top, 1 times 1 is 1, 2 times 2 is 4, and we get a probability of 1/4 just the same. Example 2. For a fundraiser, a class sells 150 raffle tickets for a mall gift certificate and 200 raffle tickets for a booklet of movie passes. Say that you buy 5 of each. What's the probability that you're going to win both raffles? Well, let's take each one individually first. So you bought 5 tickets for each, and the first one has 150 tickets. So the probability of you winning is going to be 5 out of 150. For the second one, you again bought 5 tickets, but there's 200 for this one. So that's 5 out of 200. And so then to get the probability of both of these happening, of winning both, you're going to multiply these together. So that's 25 out of 30,000, which is 1 out of 1,200. For example 3, using a standard 6-sided die, what is the probability of rolling 3, then an even number, then a 2, or a 5? Well, let's take each one of these individually. So the probability of rolling a 3, there's one way to roll a 3 out of the possible 6 sides of the dice. Then for the next one, even number, well, there's 3 even numbers out of the possible 6, so you could have a 2, a 4, or a 6. And then a 2 or a 5, well, there's 2 ways to get that. There's one way to get a 2, one way to get a 5, so 2 possible ways out of the 6. And then we're going to multiply these 3 together. So then we get, let's see, 1 times 2 times 3 is 6. 6 times 6 times 6 is 216. And then if we reduce that fraction, we get 1 out of 36. So that is the probability of rolling a 3, then an even number, then a 2 or a 5. All right, now let's go to dependent events. So again, dependent events are events that affect each other. So the outcome of the first event will change the outcome of the second event. So what we do for this, we have this notation here. This is the probability of event B happening given that event A has happened. So what that means is that event A will affect event B. And so when we calculate the probability of event B, we have to take into account the fact that event A happened. So let's look at example 4 and dive into this. Find the probability of drawing a spade, removing it from the deck, and then drawing anything but a spade. So let's first find the probability of drawing a spade. So there's 13 spades out of the possible 52 cards. And then if we remove it from the deck, then the next event, well, there's only 51 cards left for that one because we took one of them out. And so the probability of event B is affected by event A. So since I've removed that card from the deck, it changes the probability of event B happening. So then let's see, drawing anything but a spade. Well, there's 13 diamonds, there's 13 clubs, and there's 13 hearts. So that's 39 cards that are not spades. And then if we multiply these together, that will give us the probability we're looking for. So that's 507 out of 2652, which reduces to 13 out of 68. So this leads into probabilities with or without replacement. So when we're, say, drawing things off of a deck of cards, we have a choice of either putting that card back into the deck or removing it entirely. And depending on what we do there, that's going to affect the probability of the next thing that we do. So the next video for 10.5 is going to be all about doing probabilities with and without replacement.